Now, let us try to look on what is called network topology. Network topology is definition of how computers are connected. That is, you are looking on endpoints or workstation or just computers attached to a network, how they are connected to each other. That is what we define now a computer topology. Now, remember here in a computer network, we are talking about computers itself. Computer just the printer and the other device like switch, hub or routers. Now, how are they connected? We look on how they are connected. That is what you refer as network topology. In other way around, someone can define network topology as arrangement of various elements in a communication network. Now, there are two types of network topology. One is called physical network topology, and the other is called logical network topology. Now, in logical network topology here, you only define how those networked elements will communicate to one another. That is what is defining. Can be a computer, can be a switch, can be a router. You define it logically inside. By means you create just a configuration how they could communicate. And this one are defined by what we call protocols. You need to state a protocol. Protocol are a set of rules guiding how communication should be carried out. Now, the most two types of logical topology are just the broadcast one, and the other is token pathing. Now, those are two technologies that are applied in logical topology. Remember here, I said logical topology is dominated by what we call protocols. You define rules how network equipment should communicate to one another. Now, the use of broadcast, what does it indicate? Indicate each host sends its data to all hosts in a network. That is protocol number one, a broadcast type. That any station will try to broadcast it to all other connected elements. And those elements now will determine if that particular data or information targeted to it or not. If not, that data is discarded. If yes, that particular data is acknowledged. There is no order that station might follow to use the network, because it's just trying to broadcast. Whatever it gets is just broadcasting. It's sending to all. That's why we say there is no order. Now, Ethernet network is working like a broadcast. But the second one we try to see is token passing. But in this type, an electronic token is passed sequentially to each host. You follow from one, now goes to the another one, goes to another. If it reaches its own destination, now the path will not proceed again. Passing of token ends there. That is, when a host receives the token, that host can send data to a network. If the host has no data to send, it passes token to the next host and it repeats itself. That is, if this one we said in logical there is two. There is broadcast and there is token passing. Now, broadcast, if a one station is to send data and several just the elements again are connected, this one will send it to all, will broadcast it to all, and the one which is responsible will respond by sending the corresponding data. But it's always being broadcasted from this one is source or just a requesting station, and we request from all which are connected, and the one which is having now will try to respond by sending data. But if you go for token, this one source is here, and there is a station which are being requested data. The token is generated from source. Will go to a first member. Sequentially, this one will go to this one. If the destination is number one, the token will end in number one. And that particular number one will send equivalent data to source. Now, if the number one is not the destination or target computer, will go to number two sequentially. If number two is the one, now will return that data to source. If not, we'll go again to number three until it gets to a place where it can get data. That is how the two logical are working. Now, when a host receives the token that the host sent data on the network, if the host has no data to send, it passes token to the next host, and the process repeats itself several times. Two examples of network that token passes are token link and fiber distributed data. Here you have two examples. One is called token link, and the other is fiber distributed data interface. Variation of token link and FDDI is ARCnet. ARCnet is token passing on a bus topology. Now, logical topology is ending there, where only you are trying to define rules how computers or any node communicate to another node within a network. Now, there is what we call now physical topology. Physical here, you are talking about physical arrangement, how equipment are arranged now in a network. Therefore, we define as physical topology is the way in which network is laid out physically. How nodes are arranged physically. Now, the actual layout of wire or media, two or more devices connected to link, and two or more links form a topology. That is, you have some examples of physical topology. One is called mesh topology. It's just different from other topology. And here I said, in physical topology, we look on how those devices are connected to each other physically. Star topology, an example. Other type of physical topology. Bus topology, link topology, and the tree topology. Now let us see one example after another. The first one is mesh topology. Now in mesh topology, every member in a network is connected to another member within a network. That is, if I'm having only 3 members in a network, first 1, 2, 3. Now, in order to get a mesh topology, this one must be connected to this one also must be connected to this one, and this one must be connected to that one. That is mesh topology for 3 nodes. But if I'm having 4 nodes, 1, 2, 3, 4, this one must be connected, must be connected, must be connected, must be connected. And this one also must be connected to this one, and this one must be connected to this one. That is mesh topology. Now try to see how if you have 5 members. This one 1, 2, 3, 4, 5. Now the connection will start. This one will connect to this one, and this one also will connect to this one. The same number 1 will connect to number 4. The same number 1 will connect to number 3. Again, number 2, connection on number 2 goes to number 1, goes to number 3, goes to number 4, goes to number 5. And number 3 will go to number 2, number 1, number 4, and also will go to number 5. And also number 5 will go to number 1, number 2, number 3, number 4 is there. That is how mesh topology is looking like. Make sure in mesh topology every member in a network is connected to another member in a network. To every member. Must be connected to every member. Now, this type of mesh topology, in practical, we don't use mesh topology for many nodes. You use mesh topology for fewer number of nodes that you need to connect. Otherwise, everywhere there will be wires, everywhere. because every member is connecting to every other member in a network. Now we can discuss on disadvantages and disadvantage of mesh. The first advantage is the use of dedicated link guarantee that each connection can carry its own data. That is, if this one, the target is from here, from this one to this one now, this one and go to this one, will automatically send to its own destination. There is no broadcast there, because every member is connected to every member. Therefore, you guarantee that what you send will reach the destination. And this one in turn will eliminate all problems of network that may arise. Another advantage is robust. That is, if one link is unusable, it does not incapacitate the entire system. The other part will be still working. Another issue is issue of advantages on privacy and security, because every member is connected to other member in a network. Therefore, if your target is to send to number 4, you actually go to number 4. There is no need of just passing your data to number 3. No need. You just go straight to number 4. Now, the other is point-to-point links make fault identification and fault isolation easier. Because you may be in position just to isolate and identify wherever the fault is. But in mesh, you know, this device cannot communicate to this one. Therefore, the problem is only between this device and this device. You don't need to go through the entire network and do whatever. You only target which device are not able to communicate, and that is where you realize the fault is here. Now, when we meet, we discuss disadvantages of mesh topology. Yes. Sorry? Yeah.